nutshell, this is just basically saying if you have a function f plus g, it does exactly what you would expect. You find f, you find g, and then you add the two answers together. Okay, if I ask for f minus g, you just do the individual ones, subtract them. So nothing too crazy there. So we're going to start with this example. So I've given you f of x and I've given you g of x. So the first thing I asked for is f plus g of 0. Okay, if you are using the definition on that previous slide, that just means f of 0 plus g of 0. You don't really have to write that part. Basically, you plug 0 into f, we get our answer. We're going to plug 0 into g, get our answer, and then add those two together. Okay, so if I plug 0 into f, negative 4, 3 times 0 minus 4. If I plug a 0 into g, 2 times 0 squared minus 1. So when I add those, negative 4 plus negative 1, negative 5. All right. So f minus g of 4. So if you plug a 4 into f, 3 times 4 minus 4, does that give me? 8. Minus, if you plug a 4 into g, so 4 squared is 16, times 2 is 32, minus 1 is 31. So then we have 8 minus 31. Okay, you guys do C and D on your own. Grab a calculator if you need it. What'd you get for C? If you plug negative 2 into F, negative 6 minus 4 is negative 10. Plug negative 2 into G, negative 2 squared is 4, times 2 is 8, minus 1 is 7, so negative 70. D, if you plug a 3 into F, 9 minus 4 is 5. Plug a 3 into G, 3 squared is 9, times 2 is 18, minus 1 is 17. So you get 5 over 17. All right, is that part okay? Mm-hmm. All right. Next thing that we're going to talk about is the domains. Now, again, if you're looking at the Math Excel, I went ahead and put this notation. This is what they're going to tell you sometimes when you say, you know, give me a hint or walk me through this problem. All this means is your domains are like we were doing yesterday. So basically your domain is everything that makes both functions true. So it will try to step you through this process of taking F and finding the domain and taking G and finding the domain. But we can really just look at it like we did yesterday. You know, we're looking for fractions, we're looking for radicals. When we divide, we do have to make sure we're not dividing by 0. But otherwise, when you add, subtract, and multiply, the domain is the exact same on all of those. The only one that might be different is the division. So I wanted to look at an example of this. So here are two functions. I want to find these and give the domain. So f plus g of x. So notice, first of all, this time I didn't give you an x to plug in. So we're just going to take f of x plus g of x. So what is f of x?
4 square root of 4x
Plus g of x is x over x minus 3. Do we have any like terms to add? No. So that's it. That's how we write our answer. If you have like terms, you know, if you have an x squared plus a 3x squared, I want you to combine them. But otherwise, we can leave it like this. Now, the domain part is what we were doing yesterday. So I have two things. I have a square root. So if I know you have a square root, you take the thing under the radical greater than or equal to 0. So x has to be greater than or equal to 1/4. If you have a fraction, you know that the denominator cannot be 0. So x cannot be 3. So if we put those together, first one says greater than 1/4, but the second one says, well, you can't have 3, so you have to take out that 3. So it would be from 1/4 to the 3. 3 has to get a parenthesis because it can't equal union 3 to infinite. Now, the nice thing about this, when you are finding the domains, you will get the exact same domain when you add, subtract, or multiply, guaranteed. So we don't have to work this on every part. I found it for A, so that's going to be the domain for part B and part C as well. The only one that might be different is the division. Okay. Let's go ahead and do f minus g though. So f minus g, which is bf square root of 4x minus 1, minus my g, x over x minus 3. Is there anything we can do there? No, so we're done. And we already know the domain, it's the same as we just found. F times g, so you have the square root of 4x minus 1 times x over x minus 3. The only thing we could do here, this square root is really just over 1. So if you just multiply at the top, so you get x times the square root of 4x minus 1 over x minus 3. So I just wrote it as one fraction, just multiplying straight across. But again, the domain, I don't have to find it again. It's the same as before. All right, the division one. So f is the square root of 4x minus 1 divided by g. If you want to divide fractions, what do you have to do?
Flip it.
Flip and multiply. So you're just going to get an x minus 3 times the square root of 4x minus 1 all over x. Okay. Domain is the same as the other three, except we have to make sure the denominator isn't 0. If I'm looking at this final one, what can x not equal? 0. Okay, if you are starting at 1/4, do you have to worry about x equaling 0? No. No. So this one, my domain turned out to be the same as the other three. So the division is the only one that might have a different domain. You just have to look at it and see. You're just looking at the denominator. Okay. Question 6.
So if the x on that one problem is 0, that
Yeah, if this had been like, say, negative 1/4, then you would have had to take out 0. So you would have had to go from negative 1/4 to 0, and then from 0 to 3, and then from 3 to infinity. So if 0 was included, you would just take it out. Other questions? Let's do this one. We may not do all of them on here. We'll definitely do A and B. I want to practice just some of the different way functions might be represented. So part A, or the very first example we did, is like C, where I gave you two equations, you just plug in the numbers and add, subtract, multiply, or divide. I want to make sure we know how to read these if I give you a graph or something along those lines. So if I'm looking at this one, the first thing I want is f plus g of 1. So f plus g of 1. That means if x is 1, you need to add the y value of f plus the y value of g. So when x is 1, here's f. So what's f of 1? 3. G of 1 is 1. And 3 plus 1 gives me 4. F minus g of 0. So that means my x is 0. So f is here and g is here. So f of 0 is 4 minus g of 0 is, and 4 minus 0 is 4. Do you guys see where I'm getting my numbers? This one says here, x is negative 1. So you need to find y. So when x is negative 1, here's when x equals negative 1. You have to find the y values on each of these graphs. So f of negative 1. So we're looking at graph f, which is the parabola. When your x is negative 1, you're at this point on the graph. And the y value of that point is 3. G of negative 1. So when my x is negative 1, g is this absolute value graph. You're right here. What's the y value on that graph?
1.
So we have 3 times 1, which is 3. F divided by g of 2. Sorry, negative 2. So you're going to when x is negative 2 on the graph. Okay, f is my parabola. So what's your y value when x is negative 2? 0. Divided by g of negative 2 is
2.
And 0 divided by 2 is 0. So if I ask you to read these functions from a graph, I am giving you the x, you're finding the y value at that point, and then doing whatever operation. Okay, I could also give you a table, and these are even easier to find. When I want f plus g of 1, that says x is 1. So f plus g would be 1 plus 6, which is 7. When I ask for f minus g of 0, so x is 0, so f minus g would be negative 1 minus 4, or negative 5. F times g of negative 1. That's saying x is negative 1. You're just taking the value of f times the value of g. So negative 3 times 2 is negative 6. You guys see where I'm getting these? The last one, f divided by g of negative 2. So f is negative 5 divided by 0. Can you divide by 0? No, so that one is undefined. Or no solution. Alright, so I could ask you to do these types of things from equations, where you're just plugging the numbers in for x. From a graph, where I've given you the x, you're finding the y values. Or from a table. Do we need to do more of any of the three? I've got another equation one here, I've got another graph one on the next slide. Do we need more practice with any of those? The graph one, yep. So let's look at this one. So here, f is the blue one, pink is my g. So f minus g of -2. So at -2, we're right here. F has a y value of -3. Minus, does g exist at -2? No. So what does that tell me about the whole thing? No solution. If there is no point on the graph, it's no solution. F times g of 1. So when my x is 1, so now we're over here. F is right here, so that's a y value of 3. G of 1, so when x is 1, g has a y value of 1. So 3 times 1 is 3. F divided by g of 0. So f of 0 is 1. Divided by when x is 0, g is 0. And 1 over 0? No solution again.
Will it tell us every time which line is which?
Yes. So you won't have to guess at that part. Other questions? Next thing. I'm going to talk about this expression. It has a name, it's called the difference quotient. I'm really not concerned that you know what it's called right now, but we should be able to evaluate something like this. And when we do that, we do it in pieces. So what I recommend is first find f of x plus h. Second step, do the f of x plus h minus your f of x. And the third step, we will do the whole thing. That way, we're not just plugging it into this big, nasty formula at the beginning. We do one step at a time and just add a new piece to it each time. So, for example, let's say I gave you f of x equals 2x minus 3. So the first thing we need to do is find f of x plus h. That just means you go to your equation, you replace your x with x plus h. And, you know, if I'd said f of 5, you would have plugged in a 5. So when I say f of x plus h, you're plugging in x plus h. We are going to simplify this as much as we can. So all we can really do here is distribute the 2. Now, let's do the f of x plus h minus the f of x. So f of x plus h, that's what we just found. Minus, and you might want to make sure you're writing this down. How do you find the f of x? Yeah, I already told you f of x is 2x minus 3. Okay, if I want to subtract that, what do I need to do with my negative? Distribute that negative. Then add like terms, but positive 2x and negative 2x cancel. Negative 3 and positive 3 cancel. And all we have left is a 2h. That's going to be what happens every time on that second step. A bunch of stuff will cancel out. Third step, that's when I told you you're doing the whole thing. F of x plus h minus f of x divided by h. So f of x plus h minus f of x, that's what we just worked out, and we got 2h. If I divide that by h, what do you get? 2. So that is our answer. I'd like to do another one. I apologize because I know there is not much room on your handouts. If you need more space, you might need another sheet of paper. Sorry about that. I should have put this one on a new slide. So this one's going to be just a touch longer in the first step when we find the f of x plus h. Because that says you have to go to your equation and replace every x with an x plus h. Okay. Here's what makes this one longer. What do I have to do about x plus h squared?
Right after this.
Yep, that means there's two of those, so you would have to FOIL. So you get x squared plus 1xh plus 1xh is 2xh. And h times h is h squared. I'm going to tell you this will be on your homework. If you don't have this example written down, I will not help you with your homework. If you want my help later on, you have to write it down while I'm working it in notes. Okay, it's gotten kind of nasty. Have I lost anybody yet? We plugged in x plus h and we FOILed. Now we just have to distribute. So if I distribute my 3, we get 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 4. Alright, that's the first step, which is the long step. From here on out, it's going to get prettier on every step. The second thing I told you you had to do was f of x plus h minus f of x. F of x plus h is what we just worked out, and we got this thing here. Minus, what is f of x? The thing we started with. Reese, did I lose you? All right, so now what would I need to do with my negative? And then I told you every time this is all going to cancel out now. So the 3x squareds drop, my 2x's drop, my 4's drop. So I have a 6xh plus a 3h squared minus 2h left. Step 3 is when I said we're going to finish it. So all we're going to do is take the answer we just got and divide by h. When you do that, you just cancel an h out of everything, so you get a 6x plus a 3h and minus a 2. And so that is our final answer.
What's the h for?
That's kind of a calculus question. H has a purpose there. Basically for us, you're just plugging in two variables, x plus h.
Oh, so it could be really.
It could be any number. Yep. So then if we got to this and I said, okay, now h is 2, then you could plug a 2 into your final answer and get it. All right, so if I give you these, like on a test or quiz, I wouldn't just say find the difference quotient. I would say part A, find f of x plus h. Part B, find f of x plus h minus f of x. Part C, do this. So I'll tell you the steps. You just have to be able to plug things into a function and do the operation. Okay. Questions there? So I'd like to talk about just one more piece today, And this is where we will pick up next week with all this stuff. We're definitely not finishing this section today. We're just kind of getting started. So the final piece I want to look at today is compositions. You guys talked about these in Mrs. Keller's class. You know, fog and Goff. Oh, they're not so bad. So basically that's when you're doing a series of operations. You're going to take a number, you're going to plug it in, you get an answer, and you take that answer and plug it into the next one. Okay? Order is very important with those. So if I say F composed with G, that is different than G composed with F. So we have to watch that order. You might see it written with this little circle in between the two. You might also see it just written with parentheses. I typically, if I have it written the first way, I will rewrite it with parentheses because then we will work from the inside out. So we'll do, probably not all the examples, I have several on here. We'll just do 1 or 2 today and pick up with this next week. So this first one, when I say F composed with G of 1, so I'm asking you for F of G of 1. You start on the inside. So G of 1, you guys know how to do that. What does that tell me to do?
4 times 1.
Yep, plug a 1 into G. So 4 times 1, and we get out 4. So I replaced that whole G of 1, just became 4. Now you take 4 and plug it into F. So 2 times 4 squared minus 3. So we get 16 times 2 minus 3. So 32 minus 3 is 29. So it's still just plugging numbers into your functions. It's just instead of plugging the same number into both and adding or multiplying, you're just taking the answer from the first and putting it into the second one. So when I say G composed with F of 1, that's G of F of 1. So you start on the inside, F of 1. So if you go to function F and plug in a 1, what do you get out? Negative 1. So we have 2 times 1 minus 3.
How do you get negative 1?
So I plugged a 1 into F. Oops. So that gives me 2 minus 3.
Oh.
Now I plug a negative 1 into G. So 4 times negative 1 is negative 4. We'll go ahead and do C and D, and then I'll probably solve. So you can do the same function repeatedly, F composed with F of negative 2. So if I plug a negative 2 into F, negative 2 squared is 4, times 2 is 8, minus 3 is 5. So then I have F of 5. So then we plug a 5 into F. So we get 25 times 2 is 50, minus 3 is 47. Does everyone see where I'm getting these numbers? The last one, G composed with G of negative 1. So starting on the inside, G of negative 1. So you go to G. G is 4x. So if you plug in negative 1, 4 times negative 1 is negative 4. Then I asked for G of negative 4, so you go back to G, and now you plug in negative 4, so you get negative 16. This is where we're stopping today. We will start Monday, continuing with this stuff. We have about 10 minutes left of class. There is a Math Excel assignment that is already open. Now, you know how to do probably the majority of it. There are some things we haven't covered yet. So if you look at this, it's not due until like Wednesday or something next week. So we're going to have time to work on it. But I would like you to please start it, especially right now with the 10 minutes you have in class. Start it. You can skip around, go to some questions that you're sure you know how to do.